Hello everyone, I am Manoj Khara, and in this week we will see how to build a recommender system and what it is and where it is being used. So, uh, so nowadays we have lots of data in form of every form like audio, video, text, everything. Now people might be interested to see what is their likings and all, or company might be interested in showing to users that what they might like next or what is their preferences, uh, that kind of product they might wanted to show the user, so that they buy that product or they might consume that product, and ultimately a company make profits out of it. So some systems which for example, let's say Amazon need a product recommendation system, that what kind of product a user might like next, right? So if he is buying some kind of let's say laptop, then he might need a mouse for that, he might need a keyboard for that, maybe external keyboard or something like that, he might need a keyboard pad, something like that. And similarly, let's say in YouTube, if you have watched a video related to, let's say, machine learning, then he might then YouTube might wanted to recommend you next a video based on your watched history or related to that video, so that you might engage more with the YouTube. Now with Facebook also need people to make connections with more people, so he Facebook might wanted to recommend you the friends or peers which are there in the Facebook. Similarly, pages, what kind of pages you like, sports pages and any other kind of your pages you like, that Facebook might wanted to recommend you. Same with Instagram, which is a product of Facebook only. And let's say on Netflix, what kind of viewers are there, like they um, what they see, Hindi, English, demographically, let's say some area wise popular movies, all of that, right? Similarly with Spotify, people might listen to Hindi songs, somewhere Tamil songs, English songs. So it depends on what kind of business they are in, like what kind of area they are in and what kind of likings there around that area is, right? So something like that they wanted to recommend to you. Now we'll see what are the types of recommendation system, and in this course we'll cover let's say mostly two, but you can consider this also as a recommendation system. So one is you recommend based on the demographic, what place a person belongs to, a user belongs to, and what kind of uh, movies he might like, right? So let's say these are the movies recommended based on US. If somebody is from US, then he might see this kind of recommendation on Netflix, that this whatever you can see on the screen. And if a user is based on India, then he might see a different kind of recommendation. Let's say if he is based on China, then he might I don't know if that it is there, but if he might see a different kind of recommendations. Now similarly with popularity, right? So let's say what is popular in US might not be popular in India, that it might not be popular in let's say any Middle East countries, and so similar, right? So popularity is also based on demographic and all, and there is a possibility that what is popular worldwide, it might be watched everywhere, right? So something like that is also considered. So let's say there is a one website called IMDb, and they have lots of movie listing in that and rating and everything. They have datas about movies, and they wanted to build a top 50 to top 250 movies, right? So which are top 250 or popular movies, you can kind of consider that. So this popularity based filtering is different across the companies. So each company might see different kind of criteria they can build. Let's say they might say, a company might say that a popular movie is something which has 100 user rated it 9 out of 10, right? Something like that. Or let's say 70% of the raters have given it rating more than 7. Okay, so something like that could be a popular. So it depends on company to company what kind of popularity based algorithm they wanted to build. They can do it. It's simple pure math logic they might use with it, or they can go complex some neural network kind of thing also, it's possible. So we'll see how IMDb were able to find what is top 250 movies, and they come up with this formula. So we will see this, like we will try to implement this formula in Colab later on, that this other thing. So we have to take rating into consideration. You can see rating is there, then you have to kind of average the rating, then how many people actually voted or gave the rating for a movie, and some minimum votes will be should be there for a movie, and what is the mean or what is the average rating of all across the movies, right. So if you have this all values, then you can find what are the top 250 movies going to be in using this formula. Okay, so whatever this weighted rating you get, you filter out the top 250 based on that, and those are the 250 movies that IMDb shows each time, right. So that is IMDb 250 movies. So this this chart you saw, this chart which you are seeing now, is came up with this formula only, and similarly several companies, maybe Netflix also might use this and all, right. So this is one form of recommendation system you can build up, which is very easy. Now other form could be content based filtering, right. So what kind of content is, so you might require some data about the content. For example, let's say this Amazon example you can take. So it's showing related to items you have viewed. Okay, so maybe somebody has viewed a weighing machine. Now it is showing based on that. So what is a weighing machine, what is the information about weighing machine stored in the database, right. So something like that information you will require to recommend that. So let's say it's a movie data, and you might require what kind of genre that movie belongs to, who is the director, who is actor. So those kind of content if you have about that movie, then you can recommend that movie, right. So because you have watched, let's say, Home Again, then this kind of movies are recommended to you similarly, right. So so here it requires some kind of information about the products it has on their website, and then it can recommend. Now you might use a summary of a product, that is also useful. You can definitely convert it to vectors and then do it, or this kind of features are also possible. So anyway, you just need the content and you can filter them out based on that, right. So now here I'll what comes is, so let's say this is a movie 1, okay, and this is a movie 2. So why I am representing it as a vector? So let's say you have a movie 1, and for that you have several features of it, let's say genre, director, and actor, right. So and several more, but something like this. Now you can represent this as a vector, and you can plot it in n dimension space. Similarly, you can have another movie with same information about that, and you can project that in n dimension space, right. Now this movie, and let's say several movies are there. Now what you have to do in this is, you have to figure out which movies are closer to each other, or how far or how close each movies are to each other, right. So something like this, then you can kind of give. So if a person has watched this movie, then you might give him this movie as a recommendation, right. So it's just a simple logic, that you have a movie formed stored in a form of vector. Now you can find similarity or closeness of two vectors, and you can recommend based on that, right. So the number of recommendations you can keep, like let's say n number of recommendation, right. So 5, 4, 10, 20, what numbers you want to recommend, that much you have to go from that, right. So you can do one is cosine similarity, which we will see soon. this implementation of this in Colab, which is very easier. Maybe you can do correlation also between the vector, right? So you have seen that, let's say this is x, this is y something, then you can find the correlation between them, right? So something like that correlation also we can do between two vectors. Okay. Now other things you can maybe do is distance based also you can do, like we do in, let's say, KNN. KNN we need a label for that, but we can maybe just find the distance, nearest neighbor, but will not see what is the label for it, right? So we just need the distance, and whatever is coming in our distance of, based on distance who is coming closer to each other, we can rank them, and that's how we can recommend it, right? So something like that also you can do. So this is how we can do content based filtering. And next is collaborative filtering. So collaborative filtering has like there is 3 ways we can do. So in this course we will cover 3 ways you can do. One is you can match a user with user. So let's say you can say that a user 1 is very similar to user 2. So since they both are very similar, let's say if user 2 watches a movie and rates a high to it, there is a possibility that user 1 might also like it, right? So that is the idea that we follow here. And similarly we can do with movies also. So let's say we have movie 1 and movie 2. So here we say that, let's say movie 1 and movie 2 are very similar. So these two movie are similar, like earlier case we say that movie 1 and movie 2 both are very similar to each other. Then if a user has watched, let's say user, so now here comes something like user and user 2. Let's say user 1 and 2 are very similar, and user 1 has watched a movie and he liked it, right? So we don't need actually another user. Maybe let's say user 1 has watched movie 2, there is a possibility he might watch also movie 1, right? So something we can do that also. Now here it's just what kind of data you get, based on that you have to build the recommendations. So earlier we had data of genres, director, actor, and so on, right? So here we won't have that. What we will have is what so the kind of data we are going to get is something like this, a user item rating matrix you can think of. So that a user 1 has rated, let's say, this many movies, user 2 has rated some movies, and there is, so some values you can see there are the form of null which is shown is, one is nothing was represent, let's say question mark also you can consider as it's not being rated, and NA also you can consider it's not rated. I have used this because you might see one of this or maybe some of this in a data set. So I have used all of them, but it all means that the data was not present, and you have to predict that will the user 3 will like this movie or not, will user 2 will like this movie or not, will user 4 will like this movie or not. So this is the task which is there in collaborative filtering. So here you don't have data about who is the director, who is the producer, actor, anything, like you don't have the data about movie, the content of the movie, but what you have is you have the user rating of a movie. So this movie was rated by this many people, that you have, this movie was rated by this many people, and that you have. So here also you can kind of consider that so I was explaining that you might have some null values and you have to predict that here, right? So now here also you can kind of think that, let's say if you have this kind of data, a movie is what? A movie, if you have no information about the movie, but you have the user rating of that, maybe in form of this data, what you can represent is that a movie is just this factor, right? So here we will kind of consider that user 1, 2, 3, 4 are feature of the movie, and that's what movie is being represented, right? So here similarly all the movies can be represented based on this, right? So you can kind of see that sum has no values. So what we will do is we will start with making all of them 0. So here now the vector is complete, so that it will not give you any error later on when you will do the cosine similarity or something like that. Okay. So let us see what we have in collaborative filtering is it is yeah, so that's what I mentioned, that collaborative filtering. So matches user with similar interest without requiring item meta. So will not require any item data. Will just require what kind of ratings people give to this. Okay. For example, this is bestseller. This is also 4 star, 4 star, 4 star, maybe something like that. So that star and all will be required in that. Okay. Now. Yes, so collaborative filtering makes automatic predictions about interest by collecting preference from many users. So it will first, so it do one thing, it uh, collects the data about user, that what kind of product he is liking, right, he or she liking. So that he do, so collection, and based on that we have to make the prediction. And using this collection we kind of get to know about the movie itself also, right. So many so users are giving data about some kind of product, right, let's say movie. So we get to know about this also. And if user gives multiple movie reviews, right, so let's say M3, M4, so we get to know about user also. So in this way we use this network to understand about user metrics or user item. So that's what it called, user item metrics later on. So we just saw in next slide this, right. So this is called user item metrics, and that's what it forms, and from that we can make the predictions. Okay. So it's being said that users who have agreed in the past will agree in the future, something like that. So let's say who those who like action movies, they will highly likely to like the action movies. Okay. Now, so what is the difference between them? We'll just look. So in this user base we have to find a similar user, recommend items liked by similar users. So if a user likes, then B user will also like that, because they both are similar. User like you also like. So find similar items. Here we'll find the similar items, recommend items similar to the user's preference, right. So user has some preference that he might say likes this kind of items more preferably, then recommend that kind of item to him. Okay. Similarly, because you liked X and try Y, so X and Y are very similar. Okay. So let's just take this example again, so just to understand how okay. So here we comes again. So we have now what kind of data we have is, we have rating given by people for a product, right. So which is very easy way to collect, like they just have to rate the something, a product. So we know what kind of product is and what is the rating given by user. Okay. So if we have this kind of data, let's say 1 is worst and 5 is best, right. So you might have seen that most of the ratings goes like they don't have 0 involved in it, right. So they might have, let's say, lot more liked, or it might have categorical data, or it might have numerical, but it comes from 1 to 10 or 1 to 5, something like this, right. So maybe it's a thoughtful thing they have done in collecting the data, so that now what we have to do is we have to predict the values for which there is no rating given, right. So let's say 0 is also considered as no rating given. So wherever you see 0, so there is another way to so another way to represent not rated is 0 also. So that is not being rated in some way. Okay. Now we have to find similarities between this. Let's say we find similarities between movies. Okay. Now let's say a Bahubali is here, and Pathan, RRR is another movie. If they are very similar to each other, and a user one has watched Bahubali and he hasn't watched RRR, just think like that, then he might like RRR, right? So that was the idea between movie, uh, so it's movie based use or item based recommendation, okay. And so that's how we have to. So our task is that will user to like is going to like Dangal. So that is the task, right? So user 2 will like the Dangal or not. Now one way is we can figure out which movies are similar to Dangal, okay, which movies are similar to Dangal. One way is that, and another way is which user is very similar to user 2, okay. So this two tasks we have to do, user 2 or which movie is very similar to the Dangal. Now any way you can do, so this way is also valid, this way is also valid, both of the ways are being used. So you will just require one way to give a prediction out there, okay. So this is a matrix which is which has like 5 users and sorry 4 users and 5 movies, okay. So it collects like, so the total data here is 20, right? So 4 cross 20. Now let's say you have data of 1000 users and you have data of 500 movies, okay, which is very normal. But now the data which you have to store is something like 5 lakhs, right? So 5 lakhs is the number is the amount of data you have to store here, right? So is this a good way to do it? So let's say this is very small number of users, 1000 users and 500 movies only. Generally we have if I just say talk about India itself, there are more than maybe 5 lakhs 6 lakhs people. If that is the amount, then how much data we have to store in it, right? So the data storage is a problem in that collaborative filtering, data storage. And do we actually need, let's say so earlier we saw that for this movie we will require all the users rating to say that is the vector of that movie, right? The movie which are we are representing it as a vector is a users rating. Now do we actually need all the users rating? Can we throw away some users? Is it possible, or can we reduce the size of this matrix, right? So you would have seen, right? So whenever we have a huge matrix, we wanted to reduce it into a smaller size. There is one thing called SVD. We have done it, right? So SVD, what it does is we find PC and all, right? So similar to SVD, we will not use SVD here to reduce the size of the data. Of course we can do it, that is also a valid choice of doing it, and people does it actually. But what we will do is we will have another thing called matrix factorization approach, right? So let's say this data was of 1000 cross 500, right? So this was the data size we had, and which has 500,000 data points in this, right? So data in this. Now what we can do is we can make a smaller matrix out of it, which let's say 1000 let's say a matrix, and we have to multiply with another matrix. So the column of this should match the rows of the, right? So let's say this has k rows and this has k columns. Now we have 10,000 users and we have 500 movies, okay. So if this way we can divide, then maybe we can reduce the data, right? Now let's say k is, let's say just assume that k is 100, okay. Then what we'll need is we will require here we'll require 1 lakh data points here, and here we'll require 100 into 500 and something like this, right? So 50,000 here, yeah, so we'll require 1,50,000 data storage, right? So there is a huge reduction in the data. So this is the this is one simple way to reduce the data storage for this. So we'll use matrix factorization approach for this. So I'll recommend that you would watch this YouTube link given here, which is, if I so which I'll show you. So yeah, so how does Netflix recommended movies matrix factoring by Serrano Academy? You have to watch this, and this is the this is the explanation of this matrix factorization. I'll recommend that you go and watch this. Here I'll try to explain it in some words, but that is not the full explanation. Here he has given the best explanation I can find. You can maybe watch another YouTube video if you don't like this, but I would recommend this to watch. Here we'll just see what we have to do here. So we understood the idea that we needed to divide this into multiple or into two metrics now in k dimension, and of some let's say we have user. So we have user, let's say u cross k and k cross m kind of thing, right? And yeah, so p is a user cross factor and q is item cross factor, right? So this k is called factor, and we will later on you might see somewhere latent factor. That's what this factor is. Okay, now how does it work is, so let's say we have this data on movies and users. So these are the movies and these are the users. We, as I mentioned, that we have to convert question marks or any kind of null values to 0, and the matrix will look like this. Now we have to split in this two vectors. Okay, so how we are going to do that, we will see in some time. But before that, so what does it actually show here, right? So what is the information here could be captured by this, right? So let's say maybe this user and this user are very similar. Let's say u3 is, let's say 4 times of u4. It could be, right? So there is some kind of relations between each of the features, right? So feature 1 and feature 2 are related to each other in some way, and similarly movies are also related to each other in some way, right? So what we are trying to find is, we are trying to find what kind of features made a movie, right? So earlier we said that a movie is represented by users rating, right? So we consider users as a feature, right? So user 1, user 2 were the feature. But now what we'll do is we'll say that movie has some other features also, could be like internal, some features will be that let's say it is an action movie or not, and is it a romantic movie or not, something like that, right? So it's action, romantic or not, something like that. So that is, the movies have this kind of features in it, right? Internally we don't know that, but we'll be able to figure, or we'll not be able to figure out what feature will be, but some feature we have. So f1, f2 could be that features. Okay, similarly we'll have user also, right? So user is also, you can say that he is also made up of feature, that he might like action movies, and he might not like romantic movies and so on, right? So this is also how user will be featured into. So this f1, f2, you can kind of think that they kind of represented some form of features to represented a user and a movie in some form, right? So that's what a metric factorization will do. The more accurate explanation will be in this YouTube link, right? So I'll recommend you watch this, definitely watch this to understand this. But what we have is, we have this two metrics, right? So metric factorization we did, and we got p matrix and q matrix we will multiply that in this, and then after multiplication we'll have a prediction, right? So some kind of predictions will be there, and you can kind of think that we will we have to find uh, the mean squared error here, right? So mean squared error is, so this RUI, what is this? This is the original matrix we got, right? So this original matrix you can see here, that we have to subtract okay. So yes, so in this so this P transpose Q, and if you multiply that, so let's say this is a, like we saw earlier with an example, that let's say there are 5 movies, 4 users, and there is some k is the latent factor we have used. So P would be 5 cross k, and this Q would be k cross 4, or let's say if this is a user matrix, then say 4 users, and k is the latent factor we have used, and k latent factor cross 5 users, right? So you'll have similar output matrix like that, right? Now each element of that matrix multiplication, that is, you have to compare with the original matrix which we had, right? 5 cross 4 original matrix. This is the prediction matrix. You have to compare that each value, and you have to find the difference between them, square them, sum all of that. So this is same as mean squared error, right? So or you can take squared error, just squared error. That's what we are doing here, and this is the loss function we will consider for that. And here this term is called regularization parameter. So you have done L2 regularization, right? So what we do in L2 regression, we take all the thetas or all the weights of the, let's say if it's a linear regression, we take all the weights of that, and we kind of take the L2 norm of that, right? So that's what L2 regularization is that. So here P and Q are those thetas that we are trying to learn. So we'll see what we have to do next is, we will initialize random values with P and Q, and we can include bias term also. Now that is very dependent, you wanted to include bias term or not, but mostly it is being added, that you can add some bias terms to this matrix. So you can add another matrix with bias terms like that. Now with every gradient descent update, so we'll use gradient descent rule, and loss function was squared error. We will update with so we'll take the gradient of j with the p element, and then we'll take similarly with q, and we'll update that, right? So the size of this dou j by dou p will be same as what was the size of p, okay? Just in case, the shape should be same, and that's how you update all the weights, right? So weights, the number of weights in p, just p matrix is whatever the matrix size is, and similarly with q, whatever the matrix size is, right? So that many weight vectors you have to, or sorry, that many weights you have to update in this, okay? All the weights will get updated. So this is the training process of matrix factorization, and until the converges. So you will set it for some epochs, and sometimes somewhere it will converge, right? Or we will get very close to the or it will not change, something like that. And yes, so and so later on it's same process, right? So how do you predict? So this is the model you have built. So weights, this is being settled. Now you just have to multiply this matrix, and you will get the movies later, okay? Now okay, so So here the benefits are, it will handle sparse data well. So if you have sparse data, it will reduce it to some key size, right? So the size will be reduced and you can store it very well. Discover latent factor. So let's say latent factor is the features. Okay, so we didn't know what kind of feature user is, or whatever, or a movie is, but in this way you can do, or you can find out what are those factors based on gradient. So objective function is the means the squared error, and that squared error will help you to find this values of the features. Scalable to large data set, of course. So now we saw that we reduce the size of that. Better generalization, handle implicit feedback also. So implicit feedback means something which user might have. So multiple user have given 1 rating or 0 rating or something like that, and it will captures that some kind of feedback, or this movie is getting low feedback, something like that. Okay, now challenges are still the challenges that if a new movie comes up and nobody has watched it, so there is no rating for that. So if there is no rating for that, nobody has rated it, so you can't fit it here, and it will not work out using this, right? So cold start problem is there, so you can't do much with it. So some users has to watch it, and then you can put it in this matrix and rate it, and then it will work out. Hyperparameter tuning, of course, what is the value of k to choose, right? So that is a hyperparameter, 2, 3, 10, and you have to do that. Interpretability issue. So we, after initially we know that user has given, right? So as the case of SVD, after we transform it to SVD, we don't know what features are those. We just know that this is the principal component 1, 2, something. So something like that, right? So sorry, if we apply as PCA, then we don't know after what happens after PCA, right? So we just have principal components, but what they represent, what is that? So interpretability of feature is gone. Requires sufficient data, so this might require some amount of data, and there's a overfitting risk in this also. Okay. Yeah, so whatever we saw just now. Okay. Now, so we saw that we used L2 penalty, you can use L1 penalty as well, right? So this is the summary of this, that we have to leverage a user behavior pattern. We can do item based or user based classical approach. We can do metric factorization with gradient descent, which is scalable, and data quality, of course. So in real world, maybe we might use hybrid approach. So with hybrid approach is, let's say we can consider item based, user based, both approaches, and give the result out. That is a hybrid thing. Another hybrid approach is we can consider collaborative filtering and content based filtering. That is also hybrid models are being built that way also, and then we can give the predictions. Similarly, the quality matters, right? So data quality is always is a part of data science field, so that matters. Now, okay, so these are some references I have used in this. So we'll this data set is given here. You can use this. This is the data set we are going to use for building the model later on. So we'll just now see how to build the model after this in a collab in all this way. Okay, that's all. Thank you.